Okay, we're going to look at linear recurrence relations. We kind of already have the stuff we were doing last week, very similar. So let's look at this first example. Value of a house appreciates by 5% per annum. Its value at the beginning of 2000 was 80,000. Find the recurrence relation for the value of the house and calculate the expected value at the beginning of 2006. So exactly what you've done with compound interest. You start with 100%, you add on 5 and you get 105%. Which as a multiplier would be 1.05. So all we're doing is each year we're timesing the value of the previous year by 1.05. So U0, 80,000. U1, 1.05 times U0, which is 80,000, would give us 84,000. U2, 1.05 times 84 will give us 88,200. U3, 1.05 times the previous value. U4, 1.05 times that previous value, U5, 1.05 times that previous value, and U6, 1.05 times that previous value will give us that. So the value at the beginning of 2006 would be £107,207.65p. Now, if we think back to compound interest, we'd have done 1.05 to the power of 6 times 80,000. Realistically, we've times by 1, 2, 3, 4, 5, 6. We've times by that 6 times, so we'd actually get that. So that's where we get these from. So recurrence relations we can use basically like we did with compound interest. So looking at another example, a car's value depreciates by 30% per annum. Its value at the beginning of 1998 was 12,000. Use a recurrence relation to determine when its value drops below 2,000. So 30%, start with 100, take off 30 will give you 70. So 0.7 would be our multiplier. So here, UN plus 1 equals 0.7, our multiplier, times UN. So our original value, U0, is 12,000. So we do 12,000 times 0.7. Times by 0.7 again, times by 0.7 again, times by 0.7 again, times by 0.7 again, times by 0.7 again. This is dropped below 2,000. So its value will drop to less than 2,000 between 2003 and 2004. By the beginning of 2004, its value is 1,411.79, which is less than 2,000. So again, 0.7 to the power of 6 times 12,000 will give us the same value. Remember to do this as a nested thing on your scientific calculator. 12,000 equals 0.7 times ANS, and just keep pressing equals and you'll get each of these values in turn. So let's look at another example. Jim opens a savings account with £1,000. He pays in 5,000 at the beginning of each year thereafter. The rate of interest is fixed at 4.5%. How much will be in the bank after 4 years, and how many years is it before he has accumulated 50,000? So 100 add 4.5 is 104.5%. So 1.045. So that's that first bit. UN plus 1 is 1.045 UN, but he's depositing £5,000, so plus another £5,000. So he initially starts with £1,000, so we do 1.045 times 1,000, get an answer plus 5,000 will give us 6,045. Then 1.045 times 6,045 plus 5,000 will give us that. And again, so it goes, we keep going, and the first time it goes over 50,000 is 9 years. So after 4 years, 22,583.47, and after 9 years it gets over 50,000. So we can do the same thing again. So taking another example, doing a few examples for you here. A company requests permission to start dumping 10 tonnes of chemical waste per week into a sea loch. 25% of the waste will be removed per week. So how much will be there after 5 weeks, 6 months and a year. So 25% is removed, which means 75% remains. So 0.75 is your multiplier, plus we're adding 10 tonnes. So it starts off with a pristine sea loch. So we do 0.75 times 0 plus 10 will give us 10. Then we do 0.75 times 10 plus 10. And so on and so on and so on and so on. So after 5 weeks, it's 30.508 tonnes. So 6 months, 26 weeks, remember 52 weeks in a year, is 39.977. And then after 52 weeks, 39.9998. So basically 40 tonnes after a year. Similarly, for the next one, a credit card company charges 2% per month on any outstanding debt, while a minimum fixed sum of £30 has to be repaid at the end of each month. If £200 is owed initially and no other purchases are made, how many months will it be before the debt is paid off? So it's adding 2%, so it's 102%, which is 1.02, which is what our multiplier is here. So UN plus 1, 1.02 UN, but we're paying off, so minus 30. The initial debt is 200, so we do 1.02 times 200, then take away 30. Then we do 1.02 times 174 minus 30, and so on 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 until we get below 0. So the debt will be repaid after 8 months. And we could work out what the final value is. It didn't ask us to. That's something we'll come on to. But again, in terms of doing it as a nested calculation here, 200 equals 1.02 times A and S minus 30, and just keep pressing the equals button.